up a little bit. So yeah, before we start, I have a question. What makes Go special for you personally? What's your favorite feature in Go? Boring. Go is boring and it's your favorite feature. Nice. Usually people say something like Go routines or like simplicity or I don't know, like performance, like those things. Something like standard library, for example. Personally, I like all those things. And I also like the way how we test things in Go. So if we talk about testing, quite often we talk about built-in testing framework, like someone just say like, oh, it's just like a part of standard library, but I think it's a little bit bigger than just standard library. It's like a framework that lets us, for example, calculate coverage easily through the CLI tooling, like same our favorite Go commands, Go test, and then like a lot of options come for us. Then I also like what the fact how we test in Go is similar to the fact how we write applications in Go. We just write special functions that are called test functions, and the approach is very similar to what we do in the like regular code writing. Then quite often we use table-driven tests that help us structure our tests better, help us not repeat similar things and the other things like that. And plenty of people like subtests. I like subtests too, especially the fact that we can run subtests in parallel. That also saves some time and yeah, offer us some other nice things. But I actually started writing the automated tests much before then I started writing in Go. And if you ever thought like, okay, how we should write automated tests? Well, first of all, I was very impressed with the fact that it's possible to test your application by writing tests, so you don't need to test it manually. It was like 2010 probably, something like that. But later I started thinking, okay, what is the good approach? What is the right approach to start to write automated tests? And like as probably everyone, once upon a time, I saw that test pyramid, this diagram that probably everyone saw once in a life at least. So this diagram sometimes has different meanings, but in principle we have here unit tests, service tests, UI tests. Service tests are sometimes called also integration tests, and the author tells us that we should mostly write unit tests, test all our units. It's easy to write unit tests. Then on top of it, we can write some service tests to check what services work correctly. And then on top of it, there could be like a few UI tests to check that UI works correctly. Of course, because we're talking about Go and mostly backends, we will not talk about UI tests today. So this part is skipped. But overall, does this pyramid apply to the contemporary application? How the typical contemporary application look like? Okay, we still have our happy user, which probably uses a little bit different interface than 10 years ago, like maybe a mobile application. Then we have a cloud, and our services are mostly run in the cloud, and some magic happens inside the cloud. Again, because we talk about databases today, we're not going to talk about user experience on the mobile application, but maybe something about cloud is an interesting thing to think about. So, okay, we still have a test pyramid that has units, that has services, and we have this cloud, and now we need to understand where are those units and services in the cloud, and if it's possible to apply this test pyramid to this approach. Or, if it's not possible to apply the test pyramid, what is the approach? How to understand what the application needs, how to find that alternative approach that would be good, that would be suitable, that would solve the needs of the testing purposes. So my name is Elena Grahovac. I write in Go since 2014. I worked with many different teams. Some teams were mostly writing unit tests and were really happy about it. Other teams were mostly writing integration tests. I also worked in teams that didn't write many tests at all. Raise your hand if you don't like writing tests. Oh, there are some people here, nice. I will ask you later what you prefer instead. But today I want to tell you our story at FerretDB and what we do to solve our needs and what are our needs and why unit tests are not enough for us. Cool, let's start. Well, first of all, FerretDB. So FerretDB is an open source MongoDB alternative. And what does it mean? FerretDB offers users of Mongo or like other developers who want to work with MongoDB work with like an open source solution instead of MongoDB. So it is possible to use regular MongoDB drivers, but connect them to FerretDB instead of MongoDB. And as the backend, you can use, for example, PostgreSQL. So in fact, you need to deploy Postgres, then you can run FerretDB, and then you can query, like you usually query MongoDB with all the flexibility that MongoDB queries offer. So yeah, that's basically how the application should work. But that's basically our requirements. We don't have any other requirements. That's what we need to implement. Let's take a look at a typical query. Let's take a look at the data. As we work with the database, we need to insert some data and see how the data will live in the database. So yeah, that's a typical insert call for MongoDB, or in our case for FerretDB. So here what we want to do, we want to insert a document. This document has two fields. First field is called ID, second field is called V. V is an array. Yeah, if you had experience with MongoDB, you know that MongoDB works with documents, not with regular rows, how like Postgres would work, for example. Okay, so we have one document that has that meaningful field V, which is an array. Let's insert one more document, which is similar. It has another array with a couple of other values. Now let's query the collection. And so, yes, okay, we have those two documents inserted. Let's remember those documents, because these are the documents we're going to work with. These are the documents we're going to test. As we implement a database, we want to be able to sort. That's one of the operations that we always need in the database. So in case of MongoDB, it's possible to set order, like field and order. For example, in this case, we want to sort by field V in ascending order. So we set like sort V1. And we have array. So our field V is an array. So the question is how to sort those two documents by field V if we know that V is an array. In this case, we can use this rule. So in case of ascending order, if an element is an array, we need to extract minimum value and compare it. And so that's why I'm personally very excited that min now is a built-in function in Go, because we don't need to implement it manually anymore. We can just use built-in function for such purposes. Okay, so that's like the rule how sorting should work in our case. So particularly because we have those two arrays, we extract minimum value from each of them. From the first document, it will be value 1. From the second document, it will be value 3. We can use those two documents for comparison to understand how the result should be sorted. Let's implement sorting. Because we write in Go, we don't have to reinvent the wheel. We can use the standard library, the package sort. And so to implement sorting, we need to implement the interface that has three functions: len, less, and swap. If we already have a slice of the documents, we know how to calculate the length of that slice. We know how to swap elements within the slice. So we need to implement less. And we already know the rules, how to understand which document is less in case of arrays. So let's implement the function less. Again, we simplified everything. We have only one field V in our documents, and we want to work with it. So we just get minimal value from both documents. Or in case we have scalars, we don't need minimal value. We just take the scalar and compare with it. Okay, that way we have the function less. Now let's implement another operation, filtering. Filtering is another important operation. If you talk about databases, every database should be able to filter. So again, in case of MongoDB, a typical filter might look like this. For example, we might want to compare when we filter. We might want to use equal operator, or less than operator, or greater than operator, or a plenty of other operators. But again, let's focus on less than for our purposes today. So when the filter is applied for less than, and the field that we want to filter against is array, we need to check, we need to do the search in that array, and we need to check that at least one array element satisfies the filter condition. In our particular case, we have two documents, and in the first document, we have an array element that satisfies the condition. It's the element 1, so the result of the filter should be the first document. We should expect the first document when we implement such filter. Okay, let's implement the filter. We already have function less, and now we need what we use for comparison when we sort things, and now we need function less to implement less than for filter. So let's reuse it. We already have the logic, we already implemented it, let's reuse it. For example, we can create another function that will work with just any values a and b, that can check if a is less than b. Basically, the logic was already described, so we just move it to a separate function. And it's time to write some tests. Nice. So yeah, we can write our favorite test function and Go test less, t, test, and t. Then we can even use table tests to come up with similar approach to test different values, different conditions. We know what values should be expected in which cases. So, okay, we just add different test cases. We just run this function. We just check it, and okay, everything works. When everything works, it's time to basically see how the query will work. So, OK, we implemented it. Now it's time to compare how MongoDB works and FerretDB works. We have the function find. We call it against MongoDB. We are able to find the first document. We call FerretDB. We are able to find the first document. The results are equal. Comparison is correct. Everything is met. The requirements is met. Now let's check sort. Again, in case of MongoDB, we received this sort. In case of FerretDB, we received the same sort. Everything is correct. Cool. So far, everything works. Our tests covered the logic we wanted to cover. OK, now let's add one more element to our database. Let's add a document that as a field B has an empty array. Totally possible case. So as the result, in the database, we have 3 documents. The third one is an empty array. And now, because we have an empty array, we need to change the logic of our less function, because before we were only able to get the minimal value and compare. So in case of empty arrays, empty array is less than a non-empty array. That's also the logic that we can easily implement. Let's also add the necessary test cases to check that our less function works correctly. And now we are ready for another trial. Let's see how this works now. OK, so we call sort for MongoDB. We see what the empty array is first. We call sort for FerretDB. We see what empty array is also first, and the other documents are sorted correctly as well. So far, so good. Now let's filter. OK, in case of MongoDB, we still receive the same results. The first document that has the array that met the condition. And now for FerretDB. Ooh, the result is different. FerretDB is not compatible with MongoDB anymore because we have an empty array. But an empty array doesn't really satisfy the condition because it doesn't have an element that is like for this filter, that is suitable for this filter, that has elements that are less than 2. Oh no, we broke compatibility. Why it happened? It happened because of one interesting thing that we didn't know when we were writing a unit test. So when we sort, an empty array is less than a non-empty array. When we filter, an array that has elements 1 and 2 satisfy the filter less than 2. But when we filter, an empty array is not less than 2. And this is something we didn't know when we wrote the unit test. Why we didn't know it? Why unit test was not enough for us? Well, in our particular case, it was hard to model real life on a unit level because we didn't have specification, because we don't know many things about MongoDB. We only know what public documentation says. But unfortunately, public documentation says that like only those things that we knew, but we implemented, and public documentation is not specification, so it doesn't have all those tiny details, how exactly comparison should look like in which cases. So specification is not available. It means unit tests are not enough. In your applications, so that's probably for people who say that they don't write tests at all. In your applications, there are probably additional properties of the system, and this is why you don't like tests. For example, you have much bigger data sets in real life, or you have a lot of requests, or like your real system is much different than how it looks like when you develop it locally. Or maybe your service is stateful, and unit tests, again, don't know many things about stateful services. Again, systems have often failures and restarts. This is how we design systems nowadays. This is how we design microservices. We design them for failure. We expect them to be able to restart quickly. And maybe there are some other operations that can affect the system, but on the unit level, we don't know anything about those operations. The question is, will integration tests solve it? Maybe not. Maybe we need something else. Let's see later. But there is even more stronger statement. One thing is to say unit tests are not enough. We also need like integration tests. Other thing to say is unit tests are harmful. And this is the sentence I see sometimes on the internet. There are actually articles on the internet that say like unit tests are waste or unit tests are harmful. This is like nothing new. And because ChatGPT became quite popular nowadays, I also wanted to ask ChatGPT what ChatGPT thinks about it. And when I was preparing this talk, I asked ChatGPT a few months ago. And so what was the answer? ChatGPT couldn't advise against unit tests because unit tests is valuable practice in software development. So I was trying to phrase it differently, like why unit tests are harmful, why unit tests could be bad, why unit tests could be like not enough. No way ChatGPT told me anything. But we know, ChatGPT learns quickly. So when I asked ChatGPT a few days ago, it actually says that there are situations when unit tests might have some limitations. Interesting. But still, I want to stick with my own observations of why unit tests might not be enough. And yeah, I personally think there are 3 main reasons why unit tests might be harmful or not enough. First of all, like in the example I show you, unit tests give us false sense that units work correctly because we don't know about the real life. We think like, okay, we implemented this logic inside this unit, it works correctly, so my application works correctly, and that's not true. Secondly, unit tests are strongly coupled with implementation details. Again, in case of Go, quite often when we write unit tests, we write them for particular functions, and if the signature of this function is changed, we need to change the unit test. Or if we move the logic of this function somewhere else, we also need to change the unit tests, and like a lot of things are happening. It causes a lot of maintenance. And also, for example, if we learn something new about the system, we also need to consider those conditions when we prepare data for unit tests. So maintenance takes time not only in terms of refactoring, but also in terms of adding those new values when we learn something new about the system. So with that, let's try to find a way to test without unit tests, or with fewer unit tests. Let's remember what was the initial purpose of FairyDB. So the initial purpose was to be compatible with MongoDB drivers. Drivers are in libraries, frameworks, or applications. So that's what we want, compatibility with those things. And then again, let's not reinvent the wheel. We know that those tools, libraries, applications already have some tests because they are also tested somehow. So we can run those tests, we can check the results, and we can see if FairyDB compatible at some point. Then, of course, we also implement some functionality. We want to cover this functionality as well. And again, we don't need to somehow find a way how to call all those things because we have Mongo Go driver, which has a way to send requests, which has a lot of helpers or just methods to work with MongoDB. So we can just use MongoDB driver to check what results we will have. What we do, we prepare collections with various data, like remembering about empty arrays, or maybe zero values, or maybe just when we have very different data types in the same collection. So we prepare very, very different collections that contain very different data. Then we can add parallel subtests, and we can run them against different collections. So this way we can run tests a little bit faster. And then if we have a subtest that modifies the data, it means that we need a separate collection to make sure that different subtests don't corrupt the data when they run against the same data. And so, okay, we have all those things. We run such tests against MongoDB. We check what those tests pass. It means that, okay, there is some checks that work. And finally, when we have those tests, they're ready. We can run them against FairyDB, make them pass too. And so this way we can be sure that the functionality we implemented is ready. That's how basically the collections look like. It's not important to see how they are called. It's important to see how many collections we have. So most likely for every test that modifies the data, we create so many collections. Sometimes we even create separate databases. It also helps us understand how our database will work. If there is a lot of databases, if there is some collections, if there are some data in those collections, and it's more like real life situation again. The second thing we have, or like the natural approach what we decided to follow is what we call compatibility or compat tests. So we already have to run tests against MongoDB to make sure they pass. And then we run them against FairyDB. So why not run them together? So we run queries against MongoDB, we run queries against FairyDB, we receive some results, and we just can just compare those results to achieve even more compatibility, because in this case, we don't need expected results that we invent ourselves. We just use the real results that MongoDB has. And so, again, this way we just compare responses from the driver, and then we provide even more compatibility. Of course, some things are not compatible. For example, we decided to not implement not a number of values, and for incompatible things, we just document the difference, and we write special tests that shows the difference. So we write the tests that pass for MongoDB and fail for FairyDB, or the other way around, pass for FairyDB and fail for MongoDB. This way we show the difference for things that are not compatible. We also have some unit tests, but they are not maybe as unit as someone wants. Those tests check logic that doesn't depend on MongoDB behavior, because we already know it doesn't make sense to write unit tests because we don't know how MongoDB behaves. They can also, in some cases, show some non-straightforward logic, or for example, they can test some low-level things, like maybe how queries work with PostgreSQL database. In this case, we have dependencies, like database itself, so we can be sure that like those tests don't run against imaginary mocks, but they run against real applications, against real dependencies. Overall, this is how the picture looks like. So we write tests written by others, we write tests written by us. And yeah, I didn't include all the possible tests. For example, I didn't include fuzzing to this picture because fuzzing is not about compatibility. It's about how application can be broken. But in principle, we run fuzzing too. And of course, this approach is not a free lunch. For example, inserting data takes quite a lot of time. Like they have that many collections. Each collection has some data. A lot of databases are created. All of these things are happening in parallel. So inserting data is quite time-consuming. And also because, as I said already, each test that modifies the data needs to be sure that that's the only test that modifies the data. We have to create a lot of collections, a lot of databases, dedicated collections for each subtest, and it also takes some time. So we decided that we can still go with it because that's really the best way to support, to offer compatibility, to support some corner cases that are not straightforward. And so what we do when we work locally, it's straightforward. We only run the tests that cover the logic that is implemented, that cover maybe the bug fix that is fixed. And then on CI, we need to run everything. And of course, you can imagine it takes quite a lot of time to insert all the data, to run all those tests. And in like a few months ago, for example, we had a situation when integration tests were taking around like half an hour to run. So imagine, OK, you send a pull request, and you need to wait half an hour to see if tests pass. It's not really comfortable, especially because we want to develop fast. We want to have a few pull requests per day, and we want to really know early if something doesn't work. So we come up with an idea of shards that can be run separately on different machines on CI, and so that we can really be in parallel and simplify the approach. What we do, we get the names of all the tests. Thanks to Go tooling, it is possible to do all those things. We distribute those names by n shards. And then on each shard, because the tests have separate collections and databases, it is possible to run them independently. So just like each shard run their own tests. And then we gather the information from all the shards to calculate the code coverage, for example, and to calculate the other things. And this way, everything works on CI quite fast. If we want even faster approach, we can just add more shards, and then it works. So this way, it's easy to deal with code coverage. We can see code coverage right on the integration tests. We can see code coverage on CI. Quite often when people send pull requests, we see what are the lines that are not covered, and then we can ask about it. So there's no need to run those things manually. Also, because we have that many collections, it is easy to test different data types, edge cases. Every time when we see a new edge case, we just add new document in some collection, or we just add a new collection, and then those collections automatically run for all the tests. So we will see how those edge cases will work for all the operators or functions we implement. Also, well, we already have real-life queries. We already have real-life situations just because we run what Go driver offers or what other drivers or applications offer. So those are really real-life queries. Those are not imaginary subqueries or something that is on a unit level, some input for some function. That also offers us ability to follow test-driven development approach because we know what query we want to implement, with which query we can work. So this way we can write tests first and then just see where they fail and how to implement all the tiny details about empty arrays or the other things. And also, bonus points that help us prioritize the features. For example, when we run tests of some applications, existing tests of those applications, we can see which features are missing on our side, which features we need to prioritize and support first. One interesting thing, most of the drivers for MongoDB, when you call count function, they actually don't call count operator, they call aggregation operator and then count on aggregation, which is a little bit unexpected, because if there is a separate simple count, why you need to call aggregation and then do some operations in it, but this is how the driver works. So this way we learned what we need to prioritize aggregation over some other things. OK, so yeah, we met a situation where a popular testing framework or approach doesn't fit our needs. We solved it by using integration tests. Should I tell you that you should write more integration tests too? I will not. Because you should own your code. And you know what your project needs. So it's up to you to decide what is best for your project. And you are really the person who knows your project best. This is the code you write. This is the application you own. So please decide what you need. Maybe you really need more integration tests. Maybe you need more observability, like in all those cases where we have different data loads on production, and we might have like more data. Maybe it's just easier to bring more observability to production and see what happens in production. This way, yeah, maybe it's possible that we really don't need tests, we just test against production. Or maybe it's something else that doesn't exist yet, but you might be the one who can invent it. Okay, so what else I can tell you? If you're more interested in what exactly we use for testing, what is our testing approach, you can simply check out our repository, because FairyDB is open source. So feel free to take a look. Let us know what you think. Start us on GitHub if it looks interesting to you. And yes, we are open for any questions. I'm still available till the end of the conference. And FairyDB is always happy to answer any questions on Slack. We have a dedicated Slack, or on Twitter, or on GitHub. So please join us and give us some feedback. Thank you very much.